The last mode of data transfer scheme is a DMA or the direct memory access. Basically, DMA is basically used when there is a bulk of data is required to be transferred into the microprocessor. That means it has more than 1 byte of data to be transferred into the microprocessor. Basically, there are three modes of operation for this. First is a burst or the block transfer DMA. The next one is a cycle steering technique, and third one is a transparent or hidden DMA. These are the basic classifications of the DMA data transfer scheme. So first one is a burst or the block data transfer DMA. Here at least 2 or more bytes of data are transferred continuously. That's why it's called as a block data transfer scheme. Here the entire data is transferred together as one straight block. Here the microprocessor is disconnected from the main system during the data transfer. Basically what will be happening is that the microprocessor will be issued a hold signal enabling it to feed its entire data and address bus, and hence all the data and address bus are available for data transfer. Hence the processor is unable to execute any program during this information transfer. That is, when this information transfer is going on, the processor cannot transfer any other type of data, or it cannot execute any other type of data during the burst mode of data transfer. Here all the bytes are transferred from between the memory or the IO device. Once the information has been sent, the DMA controller can disable the hold signal, and hence the microprocessor is free to continue with those other activities that it had been doing previously before it was receiving the hold signal. This method is using for transfer or loading files that are very important to the memory, or for data that are very urgent to be transferred. This mode of data transfer is basically preferred. Next is a cycle steering technique. Here only a single byte of data is being transferred during the cycle steering technique. Hence, as only 1 byte of data is being transferred, this is much slower than the DMA, and hence the system gets access only during one DMA cycle only. Basically, this operation will be happening during the opcode fetch cycle. As we have already observed, during the opcode fetch cycle, the fourth T state or T4, the data, the AD bus is free, and because the AD bus is free during that cycle, what will be happening is that whichever data is required to be transferred into the microprocessor, that data will be transferred during that particular fourth T state of the opcode fetch cycle. Here, after the transfer, the hold signal is disabled and the MUP enters a slave mode. Hence, the processor gets back its control after that particular data is being sent through the AD bus during that fourth T stage of the opcode fetch cycle. Last one is a hidden DMA data transfer. This is basically one of the most slowest data transfer in the DMA sector. So basically the microprocessor executes some of its state during the float operation of the data and address bus, and hence during this because it's a floating period, that means it will be operating during some free period of the microprocessor. The microprocessor gets isolated from the main system, and if and on those occasions when the microprocessor gets isolated from the main system, this hidden DMA data transfer scheme occurs, and as no signals are issued during this mode, or we cannot observe whether this data is happening in the background or not. Hence it is known as a hidden DMA data transfer. Hence the DMA controller transfers the information byte from the external peripherals and the memory into the microprocessor without any prior knowledge of the user. Hence this mode is often called as the hidden DMA data transfer scheme.